Here's a preview of what you'll learn about corrugated plastic pipes resiliency when you watch this recently recorded webinar. As we define resiliency, discuss the impacts of disruptive events, stressors, and rapid recovery, and consider the connection between resiliency and sustainability. Defining resiliency.
A resilient product must be able to withstand or rapidly recover from disruptive events or stressors.
Resiliency is necessary to help save resources and adapt to the climate change we are already experiencing.
Disruptive events.
If we look at the types of billion-dollar events as tracked by NOAA, we'll see that fires only account for approximately 6% of the events that have occurred. However, 80% of the events were ones which resulted in flooding and extreme rain events.
You can see that increased flood magnitudes was the top response. Nearly 90% of the respondents were concerned with increased flood magnitudes, increased flood frequencies following shortly severe storms, hurricanes, tropical cyclones, about 20% concerned with wildfires, and less concerned with earthquakes. If we're going to develop some risk assessment, or if we're going to assess the impacts of these various extreme weather events on your buried drainage structures, it's not necessarily a one-size-fits-all formulation. There's going to be different events and different concerns in different regions across the U.S. and globally.
Routine stressors on buried pipe.
The recurring stressors are most often the focus of maintenance department budgets, priorities, and time.
So we asked the states to report the various failure modes out of a list of failure modes for each material and to report which was the most common type of failure they had. This was to somewhat determine some of the primary concerns and specific concerns with regards to some of these more extreme weather events and patterns. So for example, for reinforced concrete pipe, the most commonly reported failure was joint separation.
The action of water entering and exiting the pipe through the joints can lead to the erosion and displacement of the surrounding material. A properly performing joint is not only critical during an extreme event, but also during normal operations. Loss of support material around the pipe during normal operations can slowly weaken the system, which can lead to shortened service life or reduce the ability of a system to withstand an extreme event.
Rapid recovery is important for resilient products.
Recovery for the ability to recover quickly when resistance fails. Resistance at some point will always fail. Failure is inevitable. Being able to recover quickly and return to service after that occurs is very important. Additionally, due to the lightweight properties of thermoplastic, the materials can be delivered to sites with less truckloads. Less truckloads means less miles driven, which saves on congestion and pollution.
What is the connection between resiliency and sustainability?
Climate change causes these extreme weather events, more extreme weather events, and it places more demand on our buried structures and thereby increasing the importance of resiliency. So to completely uncouple these or to focus on one and ignore the other, really we're fooling ourselves with regards to our long-term solution to this issue.
A recent life cycle assessment prepared by Franklin and Associates compared North American stormwater pipe systems. This report shows that the use of thermoplastic materials, and specifically high-density polyethylene, resulted in lower greenhouse gas emissions than a traditional material such as concrete and steel. HDPE pipe produced from 50% recycled material provided the lowest greenhouse gas emissions of all materials included in this study.
We hope this short recap was helpful. To learn more about resiliency and the other topics discussed in this video, watch the full webinar.